right, folks, so welcome to SigFigs Notes Part 2. I hope that you survived yesterday's video. It's kind of rough. Today's video, again, you'll probably want to pause at different times to catch up with what I'm saying or to do several practice problems on your own to make sure that you are ready to rock. So we're going to do a lot of review today first before we do anything else, before we move on to the addition and subtraction problems. So significant figures, they show how accurate your data or your answers are, your measurements to begin with. And the rules for significant figures, so the first one's straightforward. Non-zero numbers always count as significant. So any number that's a 1, a 2, all the way up to 9, those are always significant no matter what. But then the zeros will start getting a little strange. So it depends on what kind of zero you're dealing with. There are 3 kinds. Leading zeros, so those are zeros in front of all the numbers. There are no non-zeros in front of them. So for example, 0.003 has 3 leading zeros. It doesn't matter where the decimal is. What matters is, are there any non-zero numbers in front of them? If not, they're leading zeros, and they do not count as significant. Captive zeros, so that could be something like 1002 has a couple of captive zeros. So captive zeros are always significant. Those are zeros that are stuck in between. They're held captive by 2 non-zeros. And trailing zeros, so that could be something like 10.00. So this has 3 trailing zeros. Again, it doesn't matter if the zero is before or after the decimal. What matters is, are there any non-zeros after that 0 or not? And if there are not, then they're trailing. And if they're trailing, they count only if there is a decimal. So what that decimal is saying, that person's like, hey, I didn't round to 10.00. What I'm saying is I actually measured those 3 zeros, and they just happened to land on a 0. It looks like I rounded it and just sort of skipped some steps, but I didn't. So when someone puts a decimal in there, they're saying, hey, I actually measured those values. And then we looked into multiplication and division. So multiplication and division, the number of SigFigs in the weakest measurement controls how you limit or round, okay? I'm going to do several example problems of that right now. So if we're dealing with some multiplication and division, let's do a couple of problems here. So this second problem right here, 4.35 times 2.74 times 3.008. The first thing I'm going to do is count how many significant figures each one of those values has. So 4.35 has 3 significant figures. 4.35 has 3 significant figures. I don't know why that keeps showing up like that, but spoiler alert, there we go. 2.74 has 3 significant figures. And 3.008 has 4 significant figures. So 3 SigFigs times 3 SigFigs times 4 SigFigs. That tells you that your final answer can only have 3 SigFigs allowed in it at the end. So if I were to plug this in my calculator, I'd get something like 35.8524. But since I already looked at the SigFigs ahead of time, I know that I can only keep 3 of those SigFigs. So my third SigFig is the 8, so 35.8. Now, I'm not chopping. If I were to just chop off the rest of this number, I would leave it as 35.8, but I'm not chopping, I'm rounding. So 35.8, if you round after the 8, rounds to 35.9, and that's our final answer. So please notice the difference between chopping and rounding. I rounded after that third SigFig. I like to put a box around my final answer. Division works similarly. Count the number of SigFigs. So 39 has 2 SigFigs. 24.2 has 3 SigFigs. And so that means I'm only allowed to keep 2 SigFigs in my final answer because it depends on my weakest measurement. A calculator will tell you this is 1.6116. I'm allowed to keep 2 SigFigs only. And so 1.6 are the total number of SigFigs that I'm allowed to keep here. I'll put a nice little box around that because that's my final answer. So there are some practice problems you can do here on the bell work. You can do, here's the answer key. So you guys can pause the video right now if you want to take a look at the answer key. We also have another worksheet, calculations involving significant figures, where this top half had a bunch to do with multiplication and division. Again, the answer key for that is right here, so you can pause right now if you'd like to take a look at that. Your answer key should be found on Schoology as well. And if you are not quite feeling wonderful about multiplication and division or counting in general for SigFigs, You should pause and do a lot of practice problems before we move on, because I'm about to start talking about addition and subtraction, which is more difficult than the multiplication and division so far. So I would pause if you need to do some extra practice. So now that you've had some time to practice here, we're going to move on into the addition and subtraction of significant figures. So we have a simple exercise to start off. These are not trick questions. 3 apples plus 4 apples. Okay, so let's say I know for sure I have 3 apples. I know for sure I have 4 apples. What does that get me? 7 apples. Okay, and is there any doubt about how many apples I have? Well, if I knew 3 for sure and I knew 4 for sure, then I know that I have 7 apples for sure. And that's that. But one of a slightly different situation. So we have 3 apples that we know for sure, plus 4, maybe 5 apples. So this next value is estimated. So let's see what that does to our final answer. Well, before we knew we had 7 apples, now we're like, well, it's like 7 or 8 apples. And our final answer is ultimately estimated. So a known plus a known leads to something that we know. A known plus an estimated gets downgraded to an estimated. So if any part of your addition or subtraction is estimated, that sort of lowers the value of your final answer. And then finally, if we did 3 apples plus apples, be like, Mr. Pilcher, was that an audio error? No, let me pronounce that one more time, a little more clearly. 3 apples plus apples. Like, what are you saying? Be like, yes. So you have no idea how many apples you're adding to 3 apples? So do you have any idea how many apples you have? Be like, no. 3 apples plus some unknown number of apples means you have no idea. So the weakest part of your addition or subtraction will determine how confident you are in your answer. And again, that's pronounced in case you're wondering how to pronounce that. All right, anyways. So the rules for addition and subtraction with significant figures. So let's say we had a 0.95 and we added a 0.0153. We would get 0.9653. So let's kind of break this down a little bit. So if we take a look at this, let's think about the confidence we have of each one of these. So we know this 9 for sure. So that means that we know that this 9 is a for sure value. This 5 right here is the second part of the measurement. I'm sorry, it's the last part of this measurement. And what does that mean? Well, remember the last part of a measurement is always estimated. Okay. That's how we stop measuring. So the last number in any measurement is always estimated. So this 5 is estimated. This 1 we know for sure. So before we knew the 9, but now this 6, that's estimated. We don't know that 6 for sure. Why is that? Well, because we're not positive that this is a 5. That could be a 6. This could be a 4. We're not really sure. We have no idea what comes after this 5. So even though we have a 5 down here, we really have no clue what should go there. And so that's where we're actually going to draw the line, and that's where we're going to round. So we need to kind of cut the line off right here. So this is really, if you draw a line here, so I just draw a line straight down. Oh, that's not a great line. Here we go. Draw a line straight down. So we have to round off after the 6. So 0.965 rounds to just 0.97. And so our final answer is 0.97. And those official rules are, round the answer to the last digit. You have some confidence, estimated or known. So again, we had some confidence in the 6 in the 0.96. It was estimated. It wasn't as confident as a known, but we had some confidence in it. So we always round after that last digit that we have some confidence in. And again, a known value plus or minus a known value leads to a known value. A known value plus or minus an estimated value leads to an estimated value. And a known value plus or minus an unknown value leads to an unknown value. So the rule of add and subtraction, the weakest place limits how you can round. The weakest place limits how you can round. And so you may be sitting here being like, I really don't get what you just did. Let's do some practice problems, and then we'll see how you feel, okay? So let's move on to that next slide and get some good practice in. Okay, 14.0 plus 3. Well, I'm looking at this. I'm going to put a K for known and an E for estimated. So 14.0, well, that means if it's got 3 significant figures, this one's known, and the last significant figure is always estimated. So known, known, estimated. And then with this next one here, 3, well, there's only one significant figure. So you're like, wait, is that known or estimated? Well, remember, we always end the measurement with estimation. So in other words, if there's only one value, that means that one value must have been estimated. Okay? So when we're going through this value that we calculate, we get 17.0. Well, this is a known, so the 1 is a known. Known plus estimated means that this 7 is an estimated. And estimated plus, oh, we have no idea what's after that 3. So we have no clue whether this is actually 0 or not. So the line in which we will cut this off is right here. So you notice how I have my decimals all lined up, so that way I can draw a nice crisp line at the same placeholder for all these. So this comes out to just be a clean 17, and that's my final answer right there. What about one of these next ones? Let's see here. 5.2 plus 9.49. Okay, well, this 5 we know for sure, but this, oh wow, that is a terrible K. But this 2, we don't know for sure, so that's estimated. How do you know I don't know that for sure, Mr. Pilcher? Because it's the last value of a measurement. The last value of a measurement is always estimated. Okay, with this 9, that is known for sure. This 4 is known for sure. And this last sig fig in 9.49 is estimated. So we plug this into our calculator. We get 14.69. Now, 5 plus 9, that's a known plus a known, leaves us to a known in the 1's place. So the 14 is known for sure. 2 plus 4, that's an estimated plus a known. So that means the 6 is estimated. We have no idea what goes behind that 2. And even though we know this is an estimated 9, we don't actually really have any idea if this is a 9 that belongs here at the end or not. So our last part of the measurement with some confidence is this 6. So we need to round after that right here. And remember, we're not chopping off. This doesn't become 14.6. We're rounding. So this final answer will actually be 14.7. 14.7. And the rules will work exactly the same for subtraction. And I have given you guys lots and lots of practice. Here's the second half of a worksheet. We have plenty of addition, subtraction. Answer keys right here, so you can take a picture of that, or you can pause the screen right now if you want to. But I would just spend a lot of time doing your practice problems here. Please let me know if you guys have any questions at all. And the key thing I would always suggest, so let's say I was doing this problem right here. I always line up my decimals. I rewrite it vertically, and I always line up my decimals before I do anything else. So 24.08, 12.2. I line those decimals up when I'm doing addition and subtraction. That way it's easier to know where I chop the line off. So if I plug this in my calculator, I will get, what, 36.28. And so the 2 is a known, the 1's known, so this 3 is known. This 4 is a known, this 2 is a known, so this 6 is a known. This 0 is a known, this 2 is an estimated, so this 2 is an estimated. This 8's an estimated. We have no idea what's behind this 2. So we're going to we're going to draw the line there. And so this 36.28, again, we are not chopping off, we are rounding. And so we're going to call this a 36.3, and that's my final answer. So notice how I make my life a lot easier when I line those decimals up. So that's my big tip for you guys. Good luck on SigFigs. Please let me know if you have questions, and you better believe we will do lots and lots of practice in class on Wednesday to make sure you guys are ready for your quiz on Friday. All right, folks, I'll see ya.